Look up at the night sky for a moment and imagine what it truly represents. Every tiny point of light you see is a star. Around many of those stars are planets, and around some of those planets there could be oceans, continents, and skies just like ours. Astronomers estimate that the Milky Way galaxy alone contains hundreds of billions of stars. Beyond our galaxy, there are trillions more galaxies scattered across the observable universe. The numbers become so large that they are almost impossible for the human mind to comprehend. With such an enormous cosmic stage, it seems almost certain that life should exist somewhere else out there. Not just simple life like bacteria, but intelligent civilizations capable of building technology, cities, and perhaps even spacecraft. Yet when scientists search the skies for signals, when they scan distant stars for evidence of technology, they find something deeply unsettling: silence. This silence creates one of the most famous mysteries in science, often called the Fermi paradox. The paradox is simple but terrifying. If the universe is so vast and so old, and if the ingredients for life are common, then intelligent civilizations should be everywhere. Some of them should be millions of years older than humanity. With that kind of technological head start, they could easily spread across the galaxy. A civilization that mastered interstellar travel could slowly colonize star systems one by one. Even traveling at relatively slow speeds, a civilization could spread throughout the Milky Way in a few million years. On cosmic timescales, a few million years is nothing. Our galaxy is more than 13 billion years old. That means there has been plenty of time for alien civilizations to rise, expand, and leave visible signs of their existence. Yet we see none. No alien probes, no interstellar empires, no clear signals from distant civilizations. The universe appears empty. This disturbing question led scientists and philosophers to propose many possible explanations. Some suggest that intelligent life is extremely rare. Others believe civilizations are hiding or deliberately staying silent. But one theory stands out as particularly chilling. It is known as the Great Filter. The Great Filter is the idea that somewhere along the path from simple life to advanced interstellar civilization, there is a barrier so difficult to overcome that almost every civilization fails to pass it. In other words, something in the process of becoming an advanced technological species stops most civilizations before they can spread across the stars. To understand the Great Filter, imagine the history of life on Earth as a long sequence of steps. First, a planet must form in the right conditions around a stable star. Then complex chemistry must occur to create the building blocks of life. At some point, simple molecules must assemble into the first living cells. Those cells must evolve, reproduce, and survive for billions of years. Eventually, multicellular organisms appear, intelligence evolves, tool use develops, technology advances. Finally, a civilization becomes capable of space travel and begins exploring the galaxy. Each of these steps could be extremely difficult. If even one step is incredibly unlikely, it could act as a filter that stops most civilizations from progressing further. For example, the very first step might be rare. The formation of life itself could be extremely unlikely. Perhaps the process that created the first self-replicating molecules on Earth was an incredibly rare accident that almost never happens anywhere else in the universe. If that is the case, then humanity might already be incredibly special. Life might exist on only a handful of planets across the entire galaxy. In that scenario, the Great Filter lies behind us. We already passed the hardest step, and that is why the universe appears silent. But many scientists are not convinced that life is so rare. On Earth, life appeared relatively quickly after the planet cooled enough to support oceans. Fossil evidence suggests that simple life may have existed as early as 3.5 to 4 billion years ago. Considering Earth formed about 4.5 billion years ago, life seems to have emerged surprisingly fast. This suggests that the origin of life might not be extremely difficult. If simple life forms easily, then microbial organisms could be common across the universe. That would mean the Great Filter is probably not at the very beginning of the process. The next possible step is the development of complex cells. On Earth, simple bacteria dominated the planet for billions of years before more complex cells evolved. These complex cells, called eukaryotes, contain specialized structures that allow them to perform advanced biological functions. Without them, multicellular organisms like plants and animals would not exist. Some scientists believe this step may have been extremely rare. It required one cell to absorb another cell and form a cooperative relationship rather than destroying it. This unusual event may have happened only once in Earth's entire history. If that is true, then complex life might be incredibly rare in the universe. However, even complex life might not be enough to produce intelligent civilizations. Dinosaurs ruled Earth for more than 160 million years, yet none of them built radio telescopes or spacecraft. Intelligence may require a very specific set of evolutionary pressures. The environment must reward curiosity, problem-solving, and social cooperation. It must also allow organisms to manipulate tools, which usually requires limbs capable of fine movement. Many animals on Earth are intelligent, including dolphins, octopuses, and crows, but none develop technology capable of transforming their planet. If the evolution of intelligence is rare, then the great filter may lie somewhere in the transition from complex life to intelligent life. That would mean the universe could be full of planets covered with forests, oceans, and alien ecosystems, yet none of them ever produced technological civilizations. Humanity would then be a rare exception, a species that managed to cross a barrier that almost all others failed to pass. But there is another possibility, and it is far more frightening. What if the great filter is not behind us? What if it lies ahead in our future? This idea suggests that many civilizations might successfully evolve intelligence and develop technology. They might build cities, computers, and powerful machines, but before they can spread across the stars, something destroys them. Perhaps advanced civilizations almost always collapse under the weight of their own progress. If this is true, then somewhere in our future there may be a stage that nearly every civilization fails to survive. One potential filter is self-destruction through technology. As civilizations become more advanced, they gain access to increasingly powerful tools. Nuclear weapons, artificial intelligence, genetic engineering, and advanced biotechnology all hold enormous potential, but they also carry extreme risks. A global nuclear war could devastate the planet and wipe out modern civilization in a matter of hours. Engineered biological weapons could spread uncontrollably and cause global pandemics far more deadly than anything humanity has faced before. Artificial intelligence, if mismanaged, could behave in unpredictable ways that threaten human survival. Another possibility is environmental collapse. Industrial civilizations rely on enormous amounts of energy and resources. If a species damages its planet's climate, ecosystems, or atmosphere beyond recovery, it may lose the stable environment needed to sustain advanced society. Climate change, biodiversity loss, and pollution are already challenges on Earth today. A civilization that fails to manage these problems might eventually destroy the conditions that allowed it to thrive in the first place. Some scientists also worry about technological stagnation. It is possible that many civilizations reach a certain level of development, but never manage to achieve practical interstellar travel. The distances between stars are so vast that even the fastest spacecraft humans have built would take tens of thousands of years to reach the nearest star system. If advanced propulsion technologies prove impossible or too expensive, civilizations might remain trapped within their own solar systems. Over time, they could decline or disappear without ever leaving a noticeable mark on the galaxy. There is also the possibility that civilizations simply lose the motivation to explore space. As technology advances, societies may become increasingly focused on virtual realities or internal development rather than expansion. If advanced beings create digital worlds that are more appealing than physical exploration, they might choose to remain on their home planets indefinitely. From the outside, such civilizations would be nearly invisible. Yet the most disturbing interpretation of the Great Filter is the idea that technological civilizations almost always destroy themselves shortly after reaching a certain level of power. The moment a species becomes capable of reshaping its planet or building machines more intelligent than itself might also be the moment it becomes capable of causing its own extinction. In this scenario, the silence of the universe is not a mystery, but a warning. It could mean that countless civilizations rose, developed advanced technology, and then disappeared before spreading beyond their home worlds. Imagine thousands or millions of alien civilizations scattered throughout the galaxy, each following a similar path. They discover electricity, build computers, unlock nuclear energy, and begin experimenting with powerful technologies. For a brief moment in cosmic time, their planet glows with artificial lights and radio signals. Then something goes wrong. A war breaks out. An experiment fails. A runaway technology spirals out of control. Within a few centuries, the civilization collapses and its signals fade into silence. By the time another species evolves somewhere else, there is nothing left but a quiet planet orbiting an ordinary star. If this is the truth, then the great filter represents a universal challenge that nearly every intelligent species faces. Passing the filter would require extraordinary wisdom, cooperation, and long-term thinking. A civilization would need to survive the dangerous transition from technological adolescence to true cosmic maturity. It would need to control powerful technologies responsibly while maintaining a stable planet and a peaceful global society. The frightening part is that humanity may currently be approaching this stage. In just a few hundred years, we have transformed from a species using simple tools into a technological civilization capable of altering the entire planet. We have unlocked the power of the atom, begun experimenting with artificial intelligence, and developed biotechnology that can modify the fundamental code of life. These discoveries hold incredible promise, but they also introduce risks that previous generations never had to face. The next few centuries could determine whether humanity becomes a long-lasting interstellar civilization or just another brief experiment in the universe. If we manage to avoid catastrophic wars, manage our environment, and develop safe technologies, we might one day spread beyond Earth. Colonies on Mars, habitats in space, and eventually settlements around distant stars could ensure the long-term survival of our species. But if we fail to navigate this dangerous period, our civilization might end before we ever leave our home planet. The great filter forces us to confront a deeply uncomfortable possibility. The silence of the universe might not be comforting. It might mean that intelligent life is fragile and that most civilizations never make it past their most dangerous stage of development. Instead of a galaxy filled with thriving alien societies, the cosmos may be filled with worlds where life once struggled toward intelligence but ultimately vanished. Yet there is also a hopeful side to this idea. If the great filter lies behind us, it means humanity has already overcome the most difficult steps in the evolution of life. The path ahead could be relatively open. The universe might be quiet simply because intelligent life is incredibly rare and we are among the first civilizations to appear. In that case, humanity could play a unique role in the cosmic story. We might become one of the first species to explore and populate the galaxy. Even if the great filter lies ahead, understanding the risks could help us avoid them. By recognizing the dangers of powerful technologies, environmental damage, and global conflict, we may be able to build systems that reduce those risks. Scientific knowledge, international cooperation, and long-term planning could allow humanity to survive the challenges that might have destroyed other civilizations. The Great Filter is not just a theory about aliens, it is also a reflection of our own future. It asks whether intelligence is ultimately a temporary phase in the history of life or whether it can evolve into something stable and enduring. It challenges us to consider what kind of civilization we want to become and whether we are capable of surviving the immense power we are beginning to control. When you look at the stars again, remember that their silence might hold a hidden message. It could be telling us that the path to the stars is far more dangerous than it appears. Somewhere between the birth of life and the rise of a galaxy-spanning civilization lies a barrier that most species never cross. Whether that barrier is behind us or waiting in our future may be the most important question humanity will ever face. If we succeed in passing it, we might one day fill the galaxy with life, exploration, and knowledge. But if we fail, the universe will remain exactly as it appears tonight, vast, mysterious, and eerily quiet.